here is 7. 3 plus 2 equals. Hi, so today we have yet another mathematics lessons. This one will be focused on fractions. So what fractions even are? They show us how many parts do we have from a whole. So you may know the most basic real life experience lesson, and that is when you get a pizza, it is usually sliced into several parts. Usually it's 8 slices, right? So the whole is separated to 8 parts, and then if you want to have one piece from it, be one piece missing, so you will have 1/8 of the pizza. I'll be going into the details later during the lesson. I also prepared some really nice colors to work with. So I'm basically using gouache, which is a paint. It is a watercolor based paint. So let's just look at it. So we will now make the most important thing, which is the name of the whole lesson written down, and that is, as I said previously, fractions. So now that we have that, I'll just take this pink and underline it. Okay. So, what fractions look like? It can look like this, and that is called numerator. Numerator. And then we have the middle part, numerator. So the upper part we call numerator, and then we have denominator. So the numerator is the upper part, the denominator is the bottom part of the fraction. The numerator, which is the upper part, shows us how many pieces do we have, okay? And then the denominator, which is the lower part, actually shows us the number of the parts the whole is divided into. Let's say we have a pizza. Okay. So we've got a pizza and it is sliced into 8 same or equally big parts. There will be 8 equally big parts. Okay. I'll just make the pizza. Do you want some pepperoni on it as well? You can have some pepperoni on it. Okay. We'll make the pepperoni on it now. There is 1 pepperoni, 2nd pepperoni, 3rd, 4th, 6th, 7th, 8th, and a little bit more pepperoni right in the middle. Okay, good. Now that we have the pepperoni on the pizza, we'll take a knife and we will slice it into 8 pieces. Okay. Your mom said you can have 3 slices of this pizza, alright? And the number of the slices we have is how much? Yes, correct. That is 8. So now we have 3 8s, 3 8s of the pizza. So this we really like. 8s. Now we will do some adding. So we already did go through adding in the previous lessons. If you have not seen them, please check the card. And we'll just now go and do the adding, okay? So the most important thing when working with fractions is having the same denominator. If we don't have that, we kind of have to change it to work for us. So let's start with the same denominator so that you actually see how it works. So we have, let's say, 1/4 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 + 1 1/4, plus 1/4, and that equals 2/4. Both of these numbers, 2 and 4, can both be divided by 2, which means we will try to make the fraction as small as possible. So if we divide 2 by 2, it's 1. And if we divide 2 by, or 4 by 2, we have 2. How many times can be number 2 and number 4? 2 times 2 plus 2 equals 4, which means we have this, which is 1/2 is the final result. That's perfect. Now let's try that again. So we will have, for example, 5, 8 plus 1/8, and that equals, since again we have the same denominator, which in this case is 8, and we can actually add the 5 to 1, and that is 6/8. So we do have 6/8, but that is not the final result, right? Why? Because we can make it smaller, because both of these numbers again can be divided by 2. So how many times do we have number 2 in 6? Yes, that is 3 times. So we have the number 3, and then we have how many times there is number 2 in 8? 4 times. So it's 3/4 or 3/4. Depends how you want to say it. We can also say, instead of 5/8, we can say 5 over. This is the over, and 8. Okay, let's move to another one. Let's speed it up a bit. We have this plus this equals this. Let's say we have, I'll take the blue color for the numerator. That will be 3. 3, and then we have 2. We'll make it maybe 7. 7 is a nice number. So the common denominator here is 7. 3 plus 2 equals 5. And that is the result, because we actually can't make it any smaller. None of those numbers can be divided by the same number to make it smaller. So let's move to adding fractions with different denominator. Let's say we have a pizza again. Let's say we have a pizza again. You're at a party, okay, and there is a pizza that is divided into 4 pieces only. 1, 2, 3, 4. And then there is also a cake. And that cake is divided into 8 slices, okay? So now we ate one of those slices of the pizza, and that is 1/4 of the pizza. And then I ate 3 cakes from the 8 parts it was made of. Now, since we have a different denominator, we have to make it the same. So which numbers do 4 and 8 have in common? So if we add 4 plus 4, it equals 8. So we can use 8. But if you would like to, you can even do 4 plus 4 plus 4 plus 4, and that equals 16. So 8 could be the same denominator. 8 and 16 could be denominator. And then we have 8, which by itself could be, but then we have 8 plus 8, and that equals 16. So we will have the smallest denominator possible, of course, because that's what we are always aiming for. So we have the 8 as the same denominator. So if this stayed the same, we will still have the 3 8s. But how do we get this number to be 8? We have to multiply it by 2. right? So we also have to multiply the upper number. And that, ladies and gentlemen, equals 1 times 2 is 2. So overall, we have 5 eighths. We must somehow make the denominator the same. So we take the smaller number and we multiply it so it matches the bigger one. I will now take a normal paper and we'll do the calculations just normally with a pen. So now we will do some calculations together, okay? So let's start with something really simple. If you want to take a pen and do it with me, you can. If you need to stop it at any moment, just please do. So let's start with first one. Let's say we have 7 fifths and 13 fifths. Do we have the same denominator? Do we have the same denominator? Yes, we do. And it is the number 5. So we didn't have to change anything. So it's really just 7 plus 13, which is 20. It's 20 over 5. How many times do we have 5 in number 20? 4 times. So the result is actually 4. Now if we have 7 sixteenths plus 21 sixteenths, it's the same denominator again, but this time it's actually 7 plus 21 is 28. We can divide it by 2, both of those numbers. So this is 8. We could also probably do it by 4. We could also probably do it by 4, but we will do it by 2 first, so you actually can see the progress. So this is 14. We have 14 eighths. We can divide it again by 2. This is 7, and this is 4th. How many times do we have 7 in a number 4? 1 time, and then we have 3 left, right? So we'll be 3 thirds, 1 and 3 quarters, 1 and 3 fourths, or quarters, if you wish. Then we can have 19 55s plus 6 over 55, and that is 55 again, the same denominator as always, and 19 plus 6 is 25. We can divide that by 5, and that is 5 times 5 is 25, and this is 50 plus 1 times 5, which makes it 10 plus 1, which is 11. Okay, so that is 5th 11ths of 5 over 11. Now let's make it a little bit more difficult. So we have 5 12ths plus 3 quarters. What is the common denominator? So can it be 8? No, it cannot. we always take the multiples of the smaller number. 4 plus 4 plus 4 is 12. So the same denominator will be 12. We do not have to change this at all because we already have 12. So this will stay the same. So it will be 5 plus. And how many times did we have to multiply the 4 to get 12? 3 times. So we did that. So we have to do it with the upper part, with the numerator as well. So that is 3 times 3 is 9. 3 plus 3 plus 3. Okay, 9. And now we have 9 plus 5 is 14 and 12. Now we can do what? Yes, we can divide that by 2. So it's 7/6, which is 7 is bigger number than 6, right? So how many times there is 7 in number 6? 1 time. How many is left? Yes, that is correct. 1/6. Why 1/6? Because if we have 7, okay, and 7 is basically 6 plus 1, right? So this is the one right here. This is the one right there. And this is the 6 right here. Does that make sense? There's basically 1 left from the 6. So we need another 5/6 to make it 2. Okay? Does that make sense? Hopefully. Now let's do another one. So this was A. Let's do B. We have 5/18 plus 1/2. So what will be the same denominator? It will be correct 18. So this will stay the same, right? So we have 5/18. How many times do we have to multiply to get 18? 9 times. So this will be 9 times 1 is this. So we have 14/18. We can do what? Yes. We can divide by 2, which is 7, and 18. We can't make it any smaller, so it's 7/9. Now let's do something like completely random and just do C, and that will be 19. I don't know. Plus 4 thirds. So what might they have in common? That will be really difficult. What do these have in common? It might be really difficult to just know. So what you can do is actually do 3 times 20, and that is 60, right? So we will have the same or a common denominator, 60. How many times did we have to multiply 20 to get 60? 3 times. So we will have to do 3 times 19. This is 30. 30 plus 3 times 9 is 27. 30 plus 27 is, yes, that is correct, 57. And then we have 3. How many times do we have to multiply 3 to get 60? 20 times. So we have to do the same with the upper numerator, and that is 4 times 20 is 80, right? Yes. So now we have 57 plus 80, that is 137. How many times there is number 60 in 137? We have 60 plus 60 is 120, right? That's correct. So we have 1 time, 2 times. So this is 2. And how much is actually left? So if we have 120, how much is left? 17, right? So this will be 17 over 60. So the final result is 2 17/60. 2 17/60. So this is the final result.